Hello friends, today I will explain you polarity of the bond and the dipole moment. See, in the case of the electrovalent and the covalent bond. In the case of the electrovalent, there is transfer of the electrons from matter to the non-matter. Metals they lose the electron, they become positive charge, and the non-metals they gain the electron and become the negative charge. But what happens in the case of the covalent bond? In the case of the covalent bond, sharing of the electron takes place between the atoms, and its bond is formed between the two atoms. In case of the covalent bond, whether bond is formed between the two atoms of the same molecule or between the two different atoms of the molecules. If we take the example of the hydrogen, chlorine and fluorine, here one electron from each they share and form the bonds. In the same way, chlorine atom they share one electron from each, and also in the case of the fluorine they share one electron from each atom. Now in this case, if you see the atoms of the same molecule, then the placement of the shared pair of the electron is in between the two atoms. Because of the fact both the atoms they have the same electronegativity, or we say the same number of the electrons. So in this case, shared pair of the electrons will be in between the two atoms, and these are known as the non-polar covalent bond. Again listen, whenever there is a sharing of the electron between the two atoms of the same molecule, this shared pair of the electron will be in between the two atoms, and there will be no polarity. Now what happens if this shared pair of the electron is between the two different atoms of the molecule? Listen, when the sharing of the electron is between the two different atoms of the same molecule, what will happen? Suppose here we take this example of the hydrogen and the chlorine. One electron from each they share. But in the case of the hydrogen chlorine, this chlorine is more electronegative as compared to the hydrogen. In which there is a difference in the electronegativity of the two atoms, and the shared pair of the electron will be attracted toward the more electronegative atoms. It means this shared pair of the electron will be shifted toward the chlorine, then shared pair of the electron is toward the chlorine, and here chlorine becomes negative and the hydrogen becomes positive, because shared pair of the electron is shifted toward the more electronegative atoms. In this case, this is known as the polar covalent bond. Now shifting of the electron pair is also depends upon the electronegativity, as I explained you. In this case, if you see, electronegativity of the hydrogen is 2.1 while chlorine is 3.0. It means electronegativity in the case of the HCl more of chlorine, so shifted of the electron pair is toward the chlorine. So here it becomes the polar covalent bond. Now these two opposite charge poles, they are called the polar molecules, and the bond is called the polar covalent bond. This is the polarity in the case of the covalent compounds. We can also see the example of the water, where oxygen is more electronegative than the hydrogen, then the oxygen becomes electronegative, and the shared pair of the electrons, they are shifted toward the oxygen. Now, what is dipole moment? You see, in the case of the polar molecules, center of the negative charge does not coincide with the positive charge, and there is a separation between the hydrogen and the chlorine, that is the bond length increases because of the fact that the shifting of the electron share is toward the chlorine. So, two equal and opposite charges separated by some distance, they also possess some electric dipole. Again listen, in polar molecules, center of negative charge does not coincide with the positive charge. So, two equal and opposite charges separated by some distance, they possess some electric dipole. That is, I explained you in the case of HCl. So, degree of the polarity in the molecule, that is, degree of polarity in the molecule is the dipole moment and is equal to the product of the magnitude of the charge and the distance between the charge. Again listen, in polar molecules, center of negative charge does not coincide with the positive charge. So, two equal and opposite charges separated by some distance, they possess some electric dipole. So, here degree of polarity in the molecule is the dipole moment and is equal to the product of the magnitude of charge and distance between the charge. That is, dipole moment is equal to Q charge into D, that is the distance of separation between the two atoms. So, dipole moment is equal to Q into D. Here charge is 10 power minus 10 SU and the intermolecular distance is 10 power minus 8 Armstrong. So, the dipole moment is equal to 10 to power minus 10 into 10 power minus 18, that is 10 power minus 18 SU centimeter, and it is also known as the Dipole or D. So, dipole moment in the case of the HCl is 10 power minus 18. So, this is all about polarity of the bond and the dipole moment. I think it will be clear to you. So, please, if you like my videos, please share and subscribe. Thanks very much.